Diane Burton from the University of Warwick, and I'm going to tell you about this project that I've been running over the past year. It's a collaborative project between the university, a team at the university, and Hereward College, which is a further education college in Coventry for students 16 and over who've got a range of complex needs and disability. What we wanted to do was explore whether 3D printing could help these guys to actually get involved in designing some simple products that could help them with everyday tasks and make living with their disability that bit easier. So what we did, we got a group of 15 students and we used free download CAD software and taught them how to use that software. We had a CubeX printer kindly donated by 3D Systems to be part of the project. And then that group of students was very involved in designing products that the whole college community had been involved in thinking about. So we're trying to encourage them to think about everyday problems that they got and think up some product ideas that might help to make their lives easier and solve those problems. So it worked very well. The students did learn the software very well, and we did manage to print quite a few projects with the CubeX printer. So imagine for a moment that you're a young person with disability, so like these guys here. You love all the same things that all young people love. You love music videos, you like to go out with your mates for a chat and a drink, you like fashionable clothes, you like fashionable trendy stuff around you. But you've got a disability and you're always having to ask for help with basic tasks. You're a young person though, you want as much independence as possible. Now there are products out there. There's a standard range of sort of living aids products that can help with some tasks. So things like adapted cutlery, perhaps angled cutlery that can Velcro onto your hand to use it. A range of sort of fairly simple products, but a couple of points with this. They are standard products. They just simply don't work for a lot of users because conditions present in a whole variety of ways. There's bound to be products that nobody's thought of. So potential products that could help these young people that just are not out there and not available. And then another point, they're in a standard range of colours. Now, unfortunately, a lot of that is a sort of beigey, creamy colour. Reason for that is by far the biggest market for these living aids is elderly people. So the products tend to focus on their needs and their expectations of products. So it's very rare that something is going to be designed with a young person in mind, a young person who wants to have trendy, perhaps brightly coloured, fashionable looking stuff around them. So there is a huge potential here for 3D printing to engage people in thinking, well, what sort of living aids might be useful for me? Could I have a go at getting involved in designing them? So working with Hereward College, we wanted to give these young people a chance to think about the problems they got, to think of products that possibly would help to solve that problem, to get involved in the design process. And they were very good on the CAD. We were surprised how quickly they learned to use it, to actually design the products, get them 3D printed in their favourite colour, try them out. So that's what we're trying to do, and I'm going to show you some of the products that they developed in a moment. So I think for all of us, 3D printing continues to really open up access to sort of finding that designer within. But I think for people with disability, this is really, really important because it's going to enable them to really engage in thinking about their needs and wants, and really importantly, getting actually involved in the design process, possibly to design something for themselves, but as a co-producer to help in the design, to really sort of feel empowered to be involved in that design process, not just settle for a standard range of products that are there, but to create something that's just right for them and looks right for them as well. So 3D printing for them, I think, is potentially really empowering to sort of give them a chance to do it their way and not just accept the stuff that sort of experts have put out there for you. So if we just think of some of have a look at some of the products that they made. So the young lady there on your left, she needs to use a communication aid. And all of her life she needs to use a communication aid. And that black item there with the sort of metal U-shaped stand is her communication aid. So she has to press the buttons on it to actually use it. So what was happening with that simple sort of metal stand that was supplied, it was just sliding around. Sometimes it would actually fall over and fall onto the floor, and it could get broken. So we just designed a simple stand for it with a sort of channel at the back that the wire stand fitted into. Straight away they stabilised it. If you want it to stabilise even more, you can just put some double-sided Velcro on the bottom of that plastic stand that we've printed, or double-ended suction cups. That works as well. So she's really pleased with that. That is being used every single day by this student, and it has made a real difference to her. She's really happy about it. She got to print it in blue as well, which was the colour she wanted. So the basic things in life. So these are some products that the students thought up, created, got involved in designing, that just deal with simple everyday tasks of sort of eating and drinking. So the product there on the left, that's a pot noodle holder. So a lot of these young people, they like to have a pot noodle for lunch, pot noodle for a snack. Problem is, if you're in a wheelchair, or even if you're not in a wheelchair and you've just got very limited upper body movement, you can't hold the pot noodle with one hand, particularly when it's so hot. Hold it with one hand and then tilt it and then use the fork. You know, that seems so simple to the rest of us, but so many of them can't do that. So one of the students designed this, which actually raises the pot noodle up to a better height. So it's set on the wheelchair tray, raises it up to a better height and tilts it to a suitable angle for the student to just use. The great thing with 3D printing, not only can you just print this in any colour that you fancy, whatever your favourite colour is, but you can actually change the design a little bit. So you could raise the pot noodle up a bit further, have it sat a little bit lower, change the angle that it was sat at. So this would be something, it's quite simple with 3D printing, not expensive at all to, you know, the plastic for that, perhaps £1. But it's making a real difference to people. Now, Ollie, the guy in the middle, he'd recognise this problem. He needs to drink with a straw. A lot of the students at Hereward, because of their disability, need to drink with a straw, so it's a common issue. He likes to go up the pub with his mates for a bottle of beer. He is in his 20s, although he's at college. But what he's finding is when the straw goes into the bottle, it moves around. You know, he's got enough trouble anyway trying to drink from the straw, having to keep grab the straw as it's moving around. Sometimes it would actually bob up and down in the froth and, you know, shoot out and go onto the floor, and he'd have to get somebody to pick it up. So he came up with this idea of the straw bung. Very simple. It's just a series of circles with a hole through at about a 10-degree angle. The straw goes through, sits in the top of the beer bottle. The different diameters of ring mean that he could use this. If he goes and there's a slightly smaller top of the bottle, it's not a problem. The straw bung will still work. So he was really pleased about this. He sort of thought up the idea, and literally within a few hours he'd actually got this designed, 3D printed. It took 15 minutes to 3D print on the Cubex. So he went out with it, really pleased, posted on Facebook about what he'd done, really chuffed with himself. So of course the word was out. Lots of the other students said, well, we want straw holders as well. We want them to use with a glass. So we then designed the one that's there on the top right. So that just hooks over the side of the glass. That works fine, but one of the girls actually took it out and tried to use it with a glass of wine in one of the classic bowl-shaped wine glasses, but it didn't work very well because it actually sits the straw a bit too close to the curve of the wine glass, and then it kinks. And then she was very frustrated because she couldn't get at that last bottom bit of wine in her glass. Really, really annoying. So we just did a little bit of a redesign, made the arm of it a bit longer so that the straw comes out in the centre of the glass. We then went on to do another one that's sort of in between the two in length. That works really well on the sort of angled glass. It works really great on a traditional champagne flute as well, so they can join in, you know, for celebrations, join in with everybody, and that's really, really important to them. So the next one. So do I look okay in this? So what this is about, we got a student at the college who was blind. So I said, right, well, is there anything we could do to help you? You know, and he sort of, well, no, you know, I can't see the 3D printer. I can't do CAD. And I said, well, no, but there might be some problem you've got that we could help with. And he said, well, there is something. He said, I'd really like to be able to dress myself. He said, I could dress myself, but the problem is my clothes might not match. And you sighted people, some of you might laugh at me. He didn't want that. So that was his problem he'd identified. Now, there are colour-coded buttons that you can buy for blind people. So there's a shape that represents red, one that represents blue, one for green, etc. But he said, well, I don't want those. He said, why am I interested in what's red or blue? I can't see it anyway. So that's something for you sighted people. He said, I just want my clothes to match. Simple as that. So I sort of thought, well, probably he hasn't got that many different colour trouser, but he's got a lot of different colours of tops. So got in touch with his family and ascertain that this was the fact. You've got 4 different colours of trousers, essentially. So what we did, the blue buttons there, there's 4 shapes that represent one for each trouser colour. We've agreed a place that's sewn sort of on the waistband of the trouser. And then the buttons for the tops, slightly larger, the white buttons. If it's a top that goes with the trouser colour represented by the square, you just have a square on it, little small square that he just feels. If it goes with the trouser colour represented by the round one and the triangle, it would just have a small round and a small triangle on there. If it goes with all of them, it would have all 4 on. So that we've agreed a place that's sewn on the tops, and the beauty of this is we can print whichever combinations of buttons for the top we want. We could print them in different colours, so if you got, if there was a red top, we could print a red button so it wasn't so obvious when it was sewn on the top. And he's really chuffed with this. It's his idea. Working with us, it's his idea. There's nothing out there like that at the moment, and 3D printing's allowed him to get involved and sort that problem out for himself, so he can actually get dressed himself in the morning and be confident. That's such a basic thing. So next one, I want one just like this. So this is an interesting one. This guy, Chris, has muscular dystrophy. And he'd never found any of the adapted cutlery that actually worked for him. So he's got very limited hand function, so he can't actually grip cutlery at all. He's got limited arm movement, but he can do this sort of shoveling action, and that's how he eats. So he tries to put some sort of cutlery there, and he eats like that, but what he finds is it slips out, slips on the floor. So we talked to him about, well, what did he want? He wasn't quite sure, but he thought, I need something that's going to hook over that first finger. And then I need some sort of upstand at the back to stop it falling forward and falling out of my hand. So he got a basic idea of the design. He wanted a spork end, combination of a fork and a spoon, so that he could just have one utensil that would do for most situations. And the thing you can see in the middle there, that was the model that I made for him. So I bought a spork, sawed it off, got some polymorph and some new plast, which is sort of quite sticky moulding material. With the polymorph, I've sort of rolled some out with the rolling pin, cut it with a craft knife and made the little loop, and then worked with him to sort of build up. He needed something quite chunky because he can't close his hands together that well. Put the little upstand on he wanted, and then we tried out the little loop in lots of different places. Literally, it was little more than an hour, and we got this model made. Now, I realised this was going to be really difficult to do in CAD, because he said, it's got to be just like that. That's it. This is great. I want it just like that. So we thought this is a great opportunity to see how scanning technology could be used to produce the digital file that is then 3D printed. So I took it off to the university, and they scanned it to produce the digital file. And we did print one in a plastic, which he tried, and yeah, that was great. So that was a sort of a bit of a prototype, but you can't have a sort of 3D printed plastic fork because of keeping it clean and the layers, bacteria gets caught in the layers. So we really felt this would be a good one to try and 3D print in metal, but we hadn't got that facility. So somebody from the college got in touch with Renishaw. They were really, really helpful and have offered to 3D print this fork in metal. So they've done the first iteration. The picture there on the right, this is Chris with the first iteration of the Renishaw 3D printed metal fork. Now, interesting, what we found when it was in the metal and it was very smooth, his hand sort of slid forward that bit more. So we actually need the fork now to be a little bit shorter, and this is just a sort of difference with the material and how his skin contacts with the material. So all part of the learning curve. Renishaw have been great, and they are doing another iteration of it. I know these things are quite expensive to do, but they are doing another iteration of it, which we're hoping is going to be the final iteration of the fork. So Chris is quite excited about receiving that, which he will do soon. But there's a real possibility here of being able to use sort of modelling and scanning to produce bespoke cutlery for people with conditions like muscular dystrophy. And it's really important because being able to just eat yourself, without help is really, really very important. So I think there's a lot of potential there as a real sort of possible, a social enterprise or something. So just one more. I mean, we've got a range of products, but I'll just tell you about a few of them. This is an example of where 3D printing has enabled a very cheap everyday object to be adapted so that a disabled user can use it. So this student at the college is actually a residential student. He has to take regular medication, but he really wanted to be able to manage this for himself and not have somebody coming in all the time, it's time for your medicine and everything. He wanted to be independent. Now, college rules, he needed to have this medication locked away in a safe at all times. So the picture top left here, this is just a standard mini safe that you can buy anywhere, really cheap, they're sort of under £30, but we had got one at the college that nobody was using, so potentially we got one for free that we could reuse. Now, this guy, he's sort of, his fingers are stuck sort of quite like that in a sort of knuckle formation, but he's able, just by using the knuckle on his forefinger, he can tap in the code, so that's not a problem. But what we can't do is get his fingers inside that little fiddly dial to turn it to actually get the door open. So what we did, we mocked up a potential solution, which is the one in the middle. So we just used a piece of doweling and some foam to try to get the length of it and try to sort out what would work. And we used some just electrical ties to attach it to the fiddly dial so that the mechanism of the dial would still work with this new handle. He tried that out and he could do it. He could tap in the number with his knuckle, and then he'd go like that and sort of yank on it and it would come open. So that worked. So we just took measurements off it, did a design, really easy design, just in this free download CAD software, and 3D printed it. Attached it with these are just electrical cable ties, that's all they are, but they're very strong. Use those, put the holes in the correct place, and use those to attach this new safe handle to the original fiddly mini dial. Now, this has been in use by this student for months and months now at the college, and he loves this. It's there on his wall. It enables him to be independent, which is what this is all about. So I think there's huge potential here, and what I liked about this project is this is real people trying to enable themselves to think about the problems that they've got, think of solutions and actually produce those solutions. There's nothing out there. These are simple things. They're not difficult to do. You don't need a particularly fancy 3D printer to do these. We've designed it all on free download software. This is very accessible to anybody, and for anybody with disability, I think this is a huge opportunity, and I'd just like to think other young people could have the confidence to have a go with this.